I'm going to at the moment. Hi, yes, thank you for starting the recording, Siddharth. I am going to move so that the chat is closed. Yeah, I'm going to turn off the chat for the moment and we will jump into class for today. Thanks for all the enthusiasm in the start and telling us what all coding you've done before. Also, for the duration of the class, let's make sure we don't unmute unless you're invited to unmute. Yeah, okay, great. So I'm also going to set that off. But in the last 10 minutes, we'll open it up and we can all have fun together. Okay, great. So Siddharth is one of our mentors and community leads here at Gifted World. And you're all our members. And it's really fun to, one second, somebody started something. Yes. All right. It's really fun to have these conversations, these master classes where we have fascinating topics and we take it in all different kinds of ways that you may not have explored before in school or by yourself. And Siddharth is an ecologist and he's a person who studies plants. But the funny thing about that is he's done his PhD, he's done a bunch of education stuff, and he's very fascinated by that. Guys, no sharing of whiteboards for the minute, please. Yes, cool. Okay, I'm going to hand it over to Siddharth while I set up all the things so that we're all going to be able to hear him without this distraction and disruption. And over to Siddharth.
Hi, everyone. Welcome. I'm very glad to see all of you here. Just give me a moment to share my screen. I'll do the share sound later. Great. Can you all see me?
Yes, we can see you and the screen.
Yeah. Okay, and there are a couple of unmuted participants. So if you could just fix that, Janani, that would be great. Cool. So welcome, everyone. Today's masterclass is called Encoded, How to Talk to a Computer. And I was very happy to see in the introduction part that many of you are already coding. That might scare some of the rest of you who don't know programming, but that's fine, because what we're talking about today is computational thinking. It's what precedes the ability to code. And I've met many people who have been coding for a long time or been doing computation stuff for a long time, but do not know how to do this. Right? So it's a skill that you pick up that's generally useful in life. And we've had a lot of fun teaching it over the last few years. Both Janani and I have done it in many different ways, primarily through games and challenges. Okay. And so we look at that today. I'm going to start with a story. And my slide won't change. Oh, yeah. So Jean Bobby was a prominent French journalist. Okay, he was actually the editor of France's premier fashion magazine called Elle. So he was a big shot in the journalism world. But suddenly, one night in December 1995, he had a stroke. Now, for those of you who don't know it, a stroke is a sort of a sudden injury that happens to your brain. You don't need to bang your head into anything. It could just happen just like that. And as a result of that stroke, his whole body was paralyzed. He woke up in hospital 20 days later, and all he could do was blink his left eye. That's it. Okay. But here's the funny part, right? He's a big shot journalist. He's very clever, right? His mind is perfectly working. His senses are working. He's able to understand everything. And just before this happened, he signed a deal to write a book. But now this, he's stuck. All he can do is blink his eyes. So how does he write this book? That's what we're looking at today. And we're also going to look at how could we maybe write this book better. So the answer to how he writes this book is that picture over there, right? So that's Jean Bobby, okay? So lying down in the hospital bed, okay? Yes, so I did make a video about this. So I think it might be a giveaway for those of you who saw the video. So I'll just explain this, and then if you have more things to add, I'll tell you. So what he had was he had a partner, right, who sat next to him and read out all the letters of the French alphabet. And whenever Bobby wanted to choose a letter, he'd blink and he'd choose that letter. So he wrote this whole book letter by letter. Okay. In 2 months, which is kind of crazy, right? Because most people, like, I've written a PhD thesis, which is simpler than a book. And it took me a year. I did not write it in 2 months. Okay. 2 months, 3 hours a day, 7 days a week. Okay. So today we're not dealing with the intelligence that enables you to write a book in 2 months, because that's a whole different order of intelligence. Today we're dealing with how do we count, how do we convey information when you're in this strange situation, right? So all this information, this ability to write a book in 2 months is sitting in his head. The person in front of him is very clever. They could probably write the book. If Bobby was speaking, they would have written it in maybe 3 or 4 days. But you've got this challenge of all you can do to communicate is blink. You've got so huge amount of information on one side, huge capacity to deal with information on the other side, and a really, really tiny way to communicate information in between. Okay. So if I'd like someone to raise their hand to volunteer to be Bobby while we try to communicate a word to me. Janani, could you pick someone since you can actually see everyone?
Yes. So can we get Ananya?
And whoever you are, you have to have your video on.
Yes. So let's get Ananya to do it. I'm just trying to find her to give her the option to unmute. Sorry, Siddharth, can you find her?
Ananya.
The screen share going, I'm not able to make. There you go. Ananya Murthy, I have asked you to unmute.
Ma'am, it's actually Anya.
Anya, sorry. Anya, over to
Hi, Anya. Okay. Hi. So these are all the letters in English. Okay, wait. Could everyone else just lower their hands, please? Because I can't see Anya. Okay, cool. Where's Anya? Still can't see Anya. There's Anya. Okay, cool. So I'm here. Here's the thing. I'm going to take off my earphones. Okay, so that I can't hear you. And then you and I, but I'll still be able to see you. Okay, so you and Janani discuss. Okay, and when Janani says yes, okay, that means you've decided what word you're going to tell me. And I'll start reading out the letters. Okay, and I'm still not wearing my earphones. So all you can do is raise your hand when you want me to choose that letter, and I'll write it down in my book here. Okay, so you're going to try to convey a word to me in the same way that Bobby did. Got it, Anya?
By blinking my eyes or by
raising your hand? Like, I mean, Zoom, it's going to be difficult to figure out that you blinked your... Okay, we've got two options. You can either open your mouth or raise your hand. Which one would you prefer?
I'd prefer open my mouth.
Okay, so when you say ah, that means I choose that letter.
Okay.
Okay? Let's do this. Okay, I'm removing my earphones, and when I see Janani give me a thumbs up, we're going to go.
Cool. So Anya, what shall we choose as a word?
Should I give something small or something big?
Let's do something medium.
Okay.
There are some suggestions in the chat. Class, encoded, big, school. What do you think we should do?
I think we should do class.
Class. Okay, it's class. Right? Okay, I'm going to give Siddharth a thumbs up.
A, B, C, D. A, B, C, D, E, F, G, H, I, J, K, L. Okay, so I have D, L, A, B, C, D, E, F, G, H, I, J, K, L, D, L, L. Okay. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay, I'll start again. A, B, oh, A. Okay, D, L, L, A. Huh. Maybe it wasn't D, it was E at the start, but we can figure that out. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, S. Dallas? Wait, I'm putting my earphones on. Were you trying to say Dallas and you missed an A?
No, I opened my mouth at C and you wrote D.
But what's CLLAS? Oh, classifiers.
Class.
Class. Ah, class. Excellent. Okay, so super. C. Ah, that wasn't bad. Okay. So how did that go? Janani, you can open the chat now because I'm going to be asking questions. Anya, how did that go for you? What difficulties did you have? Oh, wait, we should ask you to unmute. Huh.
I had a few difficulties, like I was focusing on the screen and your words, and sometimes I missed the letter, and sometimes you would not write it down.
Oh,
So that
but
was
I
the
wrote it down.
difficulties. So I opened my mouth at A, and then you went till Z before writing down.
Ah.
A.
No, so I missed seeing you open your mouth.
Yes.
Ha. Okay.
And then sometimes I would miss you reading out the letter.
Okay. So now those were logistical problems. I admit that. But suppose that system worked perfectly. Okay. My next question is, how can we make it more efficient? Ideas, and feel free to put it in the chat. I can see the chat because I have a second screen over here.
So let me pull out some relevant ones. Somebody's talking about Morse code. So a couple of ideas. Daivik has also suggested it, and Siddhant has suggested it.
Okay, cool. Morse code. Oh, great. Okay, yeah, I'm glad we didn't do that big word.
Avyuk says by paying attention, we can improve this.
Okay, so suppose we have just this format, right? So right now it's 1995. He doesn't know binary, and he doesn't really know Morse code. He'll have to like train himself in Morse code and then speak in that way. And that book publisher has a tight deadline. So we're just going with this format, okay, of an assistant reading out letters. Okay, the assistant is in front of him. They're going to help. Okay, he doesn't want to learn Morse code because that's a pain.
There's also binary as a suggestion.
Okay. Leaving a pause after each letter so that he can have enough time to answer while blinking. Definitely. Okay. Anyone else? So suppose we're working with the same format of reading out letters. What can we do to make this format better? Ghostwriting. Haha. No, ghostwriting, bad idea. Anyone? Like, so we're just reading out these same letters, and actually the ABCD is not what Bobby did. He was more efficient than this. Okay, which is the most common letter in the English alphabet?
Siddharth, shall I turn off the chat or you want to keep going?
I was hoping someone would chat.
Okay, we have a whole bunch of A's and E's.
A's and E's, right? Is B a very common letter? Not really. Okay, so we can answer this question sort of better by just going to Wikipedia, which is the source of all knowledge, right? And if we go to Wikipedia, it gives us this list of all letters sorted by frequency. Okay. And if we then go with that, this is what the letters look like in English if you sort it by frequency. Frequency means that E over here is the most common letter and Z is the least common letter. So those top 10 are the 10 most common letters in English. And in fact, if you add them up, it comes to about, wait, let me just tell you this. If you add up.
For just sake of focus, I'm going to close the chat for a few more minutes. Tell us when to open it again, please.
Sure. So going by those letter frequencies on Wikipedia, this top row of E until D accounts for 74% of all letters in English. But some of these letters are really far away if you go in alphabetical order, right? T, S, R in alphabetical order are way back there. So now let's repeat that whole word exercise. So raise your hands to volunteer, and let's do it instead with this set. So Janani, you can pick someone, and then again, thumbs up me when you're ready.
I'm going to ask Daivik to unmute.
Daivik himself can thumbs up me when he's ready. Oh, do you have a word ready, Daivik? Yeah, you can also just think about, wait, it's helpful if everyone else knows the word. So that's why I'm going to remove my earphones and you and Janani can figure out the word.
Okay. Daivik, what shall we do?
To the entire group, anybody has any suggestions, please message chat.
Okay, I'll open the chat.
Yeah.
Oh no, I can't see Daivik anymore. Hold on, let me lower everyone's hands.
Yeah. So Daivik, a whole bunch of suggestions in the chat. I'm going to turn off the chat, guys, because otherwise we can't read it at all. It's going too fast. Yeah. So Daivik, look through the chat. Tell me which one you're going to choose.
I think I'll choose Python.
Okay. All right, cool. So let's start then, okay?
Oh, can I see? Okay, cool. E, T, A. Okay, I'll start again because I missed it. E, T, A, O, I, N, S, H. Wait, Daivik is looking somewhere else. Is it working?
Daivik said he got muted, so I've asked him to unmute now.
Sorry, what happened?
Yeah, sorry, it got muted by mistake.
Okay, so
start
you
again.
can, okay. E, T, A, O, I, N, S, H, R, D, L, C, U, M, W, F, G, Y, P, B, V, B, V, V, P, P. Okay, then E, T, A, O, I, N, S, H, R, D, L, C, U, M, W, F, G, Y, P, Y. Oh my God, what strange word are you doing with starts with P, Y? E, T, A, O, A. O. Hello, he didn't have hands and all. Huh?
Wait. Daivik,
I'll repeat.
choose one sign, either opening your mouth or lifting your hand, and just do that. Imagine the rest of your body is paralyzed.
Okay. E, T, A, T. P-Y-T. Okay. E, T, A, O, I, N, S, H, H. Oh, are you doing Pythagoras? No? PYTH. Who else has PYTH? Okay. E, T, A, O, I, O. Python. Okay, Python. Excellent. Cool. So this could help, right? So now I have a next question. So we've figured out, right? This is probably more efficient to do this frequency sorting. But how can we make it even more efficient? Any thoughts? I'm feeling like this is too long. How can we make it even more efficient? And Janani, you can open the chat, or I'll ask a few people who raise their hands. Anagha, how do we make this even more efficient? Oh, wait, I need to ask you to unmute. Anagha vanished. This is very difficult. Okay, Aradhya, how do we make this even more efficient?
We can ask the other person to blink and we can decode the letter. Like if it's 2 times, then it's E or T or A or B.
Wait, I'll actually go back to this. Yeah, so because this is in order of frequency, probably helps if we make shortcuts for the first frequency, right?
Yes.
Okay, so you're saying make a code such that 1 blink is the 1 letter and 2 blinks is
Yes.
another letter. Okay,
Yes.
so encode letters in blinks. Okay, then let's ask someone else. Sumuk. You're unmuted. You should be able to talk, Sumuk. Yes, so what's your idea of how to make this more efficient?
I think we can just show like a display, show him like a display for seeing all the alphabets, and
Okay.
And like if he blinks once, it's equal to 1 letter, and blinks twice, another letter, like that.
But it's the same as in what was previously said, what Aryadhya said, if you can choose which letter you want to like encode. One blink means this letter, 2 blinks means that letter. Cool. So that's a particular encoding you can do. Madhuvanti?
It would be better if the person who was writing down the words which the paralyzed guy wanted to speak, if that person would be more educated in the English words, maybe he or she could guess what the next word is based on the context. Like
Definitely.
after half the word is done.
Yeah, that makes sense. Okay. Then
let's ask Srivardhan to unmute. He has an idea.
Yeah, could you ask him to unmute?
Yeah.
I'm not able to find him.
My idea is that we could break the letters into groups of 5. So if a person blinks 3 times, then the person who can speak will only ask the third group of 5.
That's very nice. Okay. So I kind of thought about it. But before we go there, before we go to the more efficient thing, how do we measure how much more efficient we are? Like, how do we know this? So Hridaya, your hand is up. How can we measure how efficient our system is?
We can know by how much we have wrote in the thing, or we can make it easier.
How? No, okay, but how? I want to measure. So first there was that ABC system, then there was that ETA system. Now there is the break things into 5 system. How do we know which system is more efficient?
The one which
Vihan,
goes faster. The one which goes faster is more efficient.
But how do you know? How can you give me in numbers which one is faster? That's the question.
The first one.
But so anyway, I'll move on. Vihan, how can we measure which is faster?
Like we can do with doing it with same resources or doing it more.
I didn't understand.
Okay, I need to frame. Give me some time.
Okay, sure. Anagha, what are your thoughts on how we can measure this?
So maybe we could ask a person to, try it out, like let's say the alphabet thing. We could ask them to, like we could ask them to tell the letters, and then we could, grow on our blink.
So, Siddharth,
Okay. Yeah.
also once you're done, Anish would be the next person to unmute.
Go ahead, Anish. So I can't find you.
Yeah, we could measure the time taken to say a specific sentence. Like for the same sentence, if we are saying in all the different techniques, we could measure the time taken to say the same sentence.
And how would you do that? You sort of have to try it out the way we just did it?
Yeah.
Okay. Cool. So I'm going to show you a couple of different options. And then I'll show you how I tried to measure the time. And we'll take a look at it. But we're not... so this is the idea that was proposed by, I forgot their name, because I couldn't see them when they were talking. Janani, who gave this idea? I forgot.
I'm sorry, there's lots of us.
Lots of people here. Okay.
In the chat also, where so many interesting ideas are coming.
Okay, so the idea of splitting it up. So here's one idea of splitting it up, right? I'm going to make 3 cards, right? Those red lines just divide this into 3 cards, and I'll hold up the 3 cards. And if he blinks once, then he wants the first card. If he blinks twice, he wants the second card. If he blinks 3 times, he wants the third card. Then I'll accordingly read out that card. Right? Or he doesn't need to blink once, twice, or thrice. It could be like I say, card 1, card 2, card 3, and he blinks for the right one. Would this work well? Do any of you see downsides to this arrangement? And you can raise your hand if you can you think of a better way than this? Trinetra, why don't you go ahead? Too many people raising their hand. Could we try and unmute Trinetra? I found Trinetra, I think. Go ahead, Trinetra.
So the downsides of this is, so the person needs to blink more, so they might get tired, and plus we can cut out all of these cards into singular ones, and then we can place them all in like a box, and we can take it out, and then if they want it, they can blink it. So if the letter is Z, then they can blink it. We can have like a code system for it.
Okay, so Trinetra, but still different cards. The issue is how do we choose, right? They have 26 letters to choose from. Now the idea is instead of starting from E, T, A, O, I start asking, maybe we should demo this, right? So essentially I'd ask, hey, is it in row 1? And if I get a blink, I start row 1. Then I say, hey, is it in row 2? And if I get a blink, then I start row 2. Or, hey, it's in row 3. If I get a blink, start row 3. That's the way that we'd go around doing this. So maybe let me ask Tarun. Tarun, what do you see as the good points or bad points of this?
This technique is good, but then I think maybe we should divide all the cards into even smaller cards.
Okay.
It makes the work even easier.
So both Arahan and Siddhant also have another idea. Siddhant, after you finish responding to that.
Go ahead, Arohan. How do we find Arohan?
Arahan.
Arahan.
So
Yes.
he
I see
asked him
Arahan.
to unmute to me.
Okay. I've asked Arahan to unmute.
Yes,
Go ahead, Arahan.
you know the computers that Elon Musk invented that you can control with your brain? You have to just put a chip in your brain and then you can control the computer just with your mind. You can use that. The book will be done much faster.
Of course, but the problem is it's 1995. Elon Musk was not around. So we have to work with 1995 situation. Okay. Who was the next person? Janani, you had one more person you wanted to. Go ahead, Siddhant.
Oh, there are two Siddhants.
Which Siddhant?
Well, just like you said, you can divide it into 3 sets, but in that also he can just choose a set, and then he can just count with his mind which letter in let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's about 10 for both the sets, so he can just count the number that the letter is on, and he can just blink those many times.
Okay, that could work, but it's the same as reading it out and getting a single blink. It would take that long, roughly. Okay. So Kyra, you're very enthusiastically raising your hand. So let me ask Kyra. Do you see any problems with this system I put in place?
So the problem is like technically I'm just like giving you an issue about how you got these letters in order. So because if it's around 1995, like Stephen Hawking would have been invented before that. Like how he used to be like how he used to like talk with the computer and all. They could have just done that to make it like more and more efficient. So why didn't they just do that instead of just blinking and blinking?
That's a good point. So here's an important thing when we're dealing with computation problems, that we're often given constraints, and within those constraints we're trying to solve it. So I agree that Stephen Hawking's methods might work. I don't know if it was already active around 1995, but maybe it wasn't well known. So within this method, how can we go get better? So I'm, in the interest of time, wow, I just saw the time. I'm going to point out what I said earlier. The problem with drawing the lines this way is that this top row is 74% of all letters in English. So most of the time, he's just going to be calling the top row. 3/4 of the time, he's just going to be calling the top row. So you're not, by this split, you're not giving that much, you're not being that much more efficient. Instead, if you group it this way, if you draw a line down the middle, right? And then I ask, are you talking about this one or are you talking about this one? And if he chooses the second one, then I go N, S, H, R, D, which are very common letters. Okay. So now I'm going to just switch my screen share. Okay. Oh, wait, actually, it's the same. Okay. And show you how we can build costs around this. Okay. So I made a spreadsheet, okay, that actually calculates these costs for different ideas of how to do this. Okay. And we'll go into how to build this. We'll spend about 10 minutes on that, and then we'll continue with the rest of the class. Okay. So to start off with, we make a list of letters. Okay. And then we can just put the cost as how long we want to calculate a cost of saying a word, which is how much time will it take to say a word. So suppose my word is only AAA, or for any given letter, we can calculate a cost. And if we're following that ABC alphabetical screen, then the costs are just as per the letters, right? So if I want to say the letter E, it takes me 5 units of time to say the letter E. If I want to say the letter J, it takes me 10 units of time. So if I want to think about the word class, CLASS, the cost for the word class is 3 plus 12 plus 1 plus, where's S? Plus 19 plus 19. Right? because in order to get to S, I need to say A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U. I skipped S. P, Q, R, S. Right? So that's 19 letters. So in order to say the word class, I need to take that long to do it. But now I also have a column that is the frequency of this letter in the English language. Again, from Wikipedia, as I said earlier. And I can sort the letters as per that. And we get this set. So now I can fill in costs for this set. So now instead of A being 1, E becomes 1. T becomes 2. Right? And so now if I follow this frequency method, if I follow the frequency method, I can set up costs like this, where now the cost of the letter C is 12. Whereas if I follow ABC method, the cost of the letter C is just 3. Okay. Then we can go to this split. Okay, if I split it down 3 ways like this, that means what is the cost of letter E in this new format? Okay, where I'm splitting it this way. So I first need to ask among the 3 cards, and then I need to put in, then I start in that letter. So if you could open the chat, Janani, what's the cost of the letter E in this new format? How many blinks does it take? How many letters do I have to read out to get to letter E? Excellent. I'm seeing a mix of 2s and 1s, and the 2s are right because I first need to show the first card, the first set, and then he says, I want that first set. And then I say the letter E, and then he chooses it. Right. So the lowest cost is actually 2, not 3. Okay. So now in the first, if I want to say O, what does the cost of O become? O is the 4th letter on this set. So what's the cost of O? Okay, I'm seeing 5s, and you're right. The cost of O becomes 5. So this is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, what's the cost of L? What becomes the cost of L? How many choices do I have to give to him before we can get to L? Oh, Janani, can you enable the chat, or it's enabled? Okay.
It's enabled to us. Folks, put your answer in once. Okay, if you put it in too many times, you're just not able to read what's happening.
Oh, can you make a Gifted World co-host? That's my second computer that's looking at the chat. Okay, so the cost of L is not 12. So D was 11. Okay, and the cost of L is now 3. Right? Because you show the first, you show the second card, he says yes. And then you say L and he says yes. So 3 interactions have happened. Okay, so over here, we want L to be 3. And like that, we go down 7, 8, 9, 10, 11, 12.
Hi, sorry, sorry to interrupt. Guys, once. I respond to a question once, yeah? If you put it in 50 times, I'm just not able to read. I'm losing out some comments from interesting people in doing that. We'll get the chance to like bombard the comment section after class is over. Okay, we'll do that. Store the energy and keep it. In class, respond once to one question.
Okay, and so then finally V, K, J, X, Q, Z. So E took 2. The cost of E was 2. The cost of L was 3. And therefore, the cost of V becomes 4. Because you've shown 3 cards, and then you're choosing the 3rd card. So the cost of V becomes 4, 5, 6, 7, 8, 9. Okay. So now here's the fun thing. So in a similar way, we can do the next situation, right? If I split it down the middle, then the cost of E doesn't change, right? This still goes 2, 3, 4, 5, 6. So the first 5 letters are the same, but N now becomes 3, right? Because n is in the second card. So I show the second card. Okay, I've shown the first card, he said no. I show the second card, he says yes. And then I say n and he says yes. So n, the cost of n becomes 3, 4, 5, 6, 7, right? So ETAOI, which if you add them up is 44% of the whole English alphabet is just those 5 letters. So I'm able to get at 44% of the English alphabet at a cost of 2 to 6, which is a lot more efficient than the alphabetical system, which would get me there at a cost that can be 15 or 20. Okay, so put this aside, and so now what I've done is I've actually put these costs in for alphabetical, for going by frequency, by splitting it 3 times horizontally, by splitting it 2 times vertically, and I also put in a split 6, which is if we do it this way. So this goes back to that original session idea of doing it in sets of 5, right? Because this is 5 letters, 5 letters, 5 letters, 5 letters. Now, this fun spreadsheet, which I will share with you later, does this calculation already, and it tells you the costs of the different methods. Okay, so alphabetical is A to Z, frequency is ATAOI with no splits. Split 3 is that vertical split that we said, that like splitting it horizontally, that's probably not so good. Split 2 is having only 2 cards, and split 6 is having it in groups of 5. Now I can put any word we want over here, like Python. And you can see that Python going alphabetically was 98, which is huge. And if we go by that frequency method, it's only 57. Even that drops down hugely when we go to the split by 2 or split by 6. Okay, so and I'll send the spreadsheet. Why don't people send me words that they'd like tested out? Or Janani, since people are sending you in, what words do you think would be interesting to test against this mechanism? Apple.
Encoded.
Okay. So Apple, hey, look at that. Apple is actually more efficient if you go alphabetically than if you go in that frequency order. You see that? What fun. Okay, then Encoded. Encoded is, the same cost as Apple if you go alphabetically. But clearly the split 2 and split 6 is far more efficient. However, here's the funny thing. In so many situations, you're seeing split 6 is not more efficient than split 2. So that's basically saying that this is not very much more efficient than this, right? Where we think that was a lot more different. Okay, any more words? Let's run a few more. Hippopotamus.
There's the big word that everybody is very excited about, which I can't even.
That one. I don't think my spreadsheet has that many letters. I've built it for like 40 letters, and that looks like more than 40.
But if you want to give it a try, put it in the chat. But apart from that, there's
I mean, I did do supercalifragilisticexpialidocious. Yes. What? Look at that. For this particular word, the most efficient is that split 3 thing, which is this one. Okay, for those of you who know Mary Poppins, for that word, this split is actually the most efficient, not the other ones that we thought would be the most effective. I don't know if these, maybe I should have made my spreadsheet bigger.
So communication is another word.
Okay, communicate. I've made this too big. Let me make it 125. Communication. What's the most effective for communication? Again, split 3 is the most effective for communication. This is so strange.
Karma really wants the word the, THE.
The. Okay. So we've rarely seen a situation where, so just from the little testing we've done, this is as effective as this. These two things are equally effective in all the words we've tested, which is curious. Like I'd have expected this to be a lot more efficient, but just putting this simple split line down the middle is making a big difference. Okay, neat.
Do that more words or?
Fine. No, I don't think I want more words because I have some quiz questions for all of you.
Then I have a suggestion. Folks who are giving me words, we will send you this sheet at the end of the class and you can, to your heart's content, put a whole bunch of words in. Okay?
Yes, but don't mess up with the formulas elsewhere in the sheet. Okay, I'll download it and send it to you. If you do stuff with the formulas, stuff will get messed up. So don't worry about that. Okay. And I'm happy to answer questions about how actually to make sheets like this. The answer is I asked ChatGPT for parts of it, but otherwise I knew the rest. Start from here. Okay, cool. So moving on. There are some further complications which we actually ran into while we were doing our session. How do you put punctuation? Spaces, commas, full stops, new lines. Okay, and then, and you also said, can't my assistant just guess the next word? That would be really helpful. And in fact, I can, within a Google Sheet itself, a spreadsheet, we can design a spreadsheet such that it guesses the next word, the autocomplete thing that we're very used to our phones doing. And here's the big deal, right, which happened in the very first session with Anya. What if you make a mistake? Right? I made a mistake. I chose D for the letter C, and that poor girl she couldn't do anything. Right? If she opens her mouth, I'll pick a wrong letter. So we need to have some kind of like emergency signal for this to work, right? So there are many more sort of details that we can add on to this. But for now, I'm going to let it be. And also, yeah, the same thing, like what if an assistant misses a blink, right? Which also happened. So you go all the way to the end and then you come back to the start. Okay, that one is if you miss a blink, that's relatively easy, right? You know, the assistant knows that go all the way to the end and come back to the start. So now I have some applications of this in other spheres of life. Okay, so first, this is a quiz question. What do you think this image represents?
I've opened up the chat. Respond once, please.
So what do you think this image represents? And you can start putting in, like, so there are lowercase letters and there are also uppercase letters. And there are numbers. And strangely enough, there are this EN, QD, FFI, FL. Okay, a couple of people are saying a keyboard, but why would you want the E key to be why would you want the keys to be so big? The original typewriter, a stenograph, a frequency keyboard. Okay, I'm liking the ideas that are coming in so far. Okay. So this predates typewriters, this predates keyboards. It was actually, the technology we're talking about was invented in the 11th century in China. A person named Gutenberg is pretty famous for this in Europe, even though he was like 500 years later than the Chinese.
Srinivas has messaged me privately to say the printer thingy in olden days.
Anyone else? Alien language? Printing press. Excellent. Yeah. So someone has said printing press. That's the printer thingy in old days. Okay. So this is what's called the California case. It was made around the 1900s. Okay. As storage for individual letters of a printing press. It looks something like this. Okay. So movable type in a printing press, what they're doing is they have these individual blocks that have the letter on it. Now, when you're trying to make a page of a book, they're picking up individual letters. So you want a lot of E's because E's are very frequent. So you want a lot of E's because you're picking up that block, putting it on a sheet. You're picking up that block, putting it on a sheet. You're making the whole page, and then you're pressing that in ink and you're putting it on the page. You're pressing that in ink, you're putting that on the page. That's a printing press. So this is a very nice depiction of the importance of the frequencies of different letters. That's why E is so big. And clearly FF and FI come very often in letters. And that's why having them together is helpful. Okay, so that's one fun thing. Now we come to keyboards. Okay, so I am going to try and find the top most used keys as per that original thing, right? So this is the keyboard we're all used to. Where are the top 10 most important keys? There's E, there's T, there's A. Sorry, Zoom is giving me things. There's E, there's T, there's A, there's O, there's I, N. Do you see something weird about this? Like E, T, A, O, I, N. There was R. There was S. There was D.
Says equally distributed for both hands to make it faster.
Equally distributed for both hands to make it faster. But there's this funny situation, right? When you're typing, your hands are actually resting over here. Okay? And all of those keys are very far away.
Yeah, in fact, CC has just messaged that they're all far apart so that the keyboard doesn't malfunction.
Right? So here's the funny part. This keyboard was designed by the Remington typewriter company because when you're talking about a physical typewriter, if two keys right next to each other get pressed very fast, they'll jam and they'll get stuck. So this keyboard was intentionally designed to slow you down in typing. For typewriters 100 years ago, and we're still using the same keyboard. A keyboard that's designed to slow us down in typing. Okay, it's designed so that the idea was that you should have more space between keystrokes so that you're not able to type two keys very rapidly. There were several other keyboards that were designed, one of which, when I initially got a smartphone about 9 years ago, I said, hey, I knew about this keyboard thing and I was like, why should I use a keyboard that's slow? So when I'm using a smartphone where I am not using all my fingers and I'm just using two thumbs and therefore it makes no difference, I'm going to use that keyboard. Oh, sorry, I'm going to use this keyboard. So for about 6 years, if anyone picked up my smartphone and tried to text with it, they'd find this keyboard and they'd be very confused. However, if you think about the most common letters in the English language, you have E, you have T, you have A, you have O, you have I, you have N, S, finger at all. So linked to what we were just talking about, okay, this keyboard design also shows up as a way that the thing we've been talking about makes a difference. Okay. And finally, because someone brought up Stephen Hawking, I want to share with you a short 2-3 minute video about Stephen Hawking, for which I need to just stop my share. And that would, and with that, we can move to the questions part of the class. Okay, so for those of you who don't know, Stephen Hawking is a very famous theoretical physicist who landed up with a condition called ALS, neurodegenerative disorder, which what it meant is progressively he lost the function of his muscles, the control over his muscles. So here was a man, again, we're in the same situation, right? Lots of very clever ideas in there.
I think Siddharth has frozen. He will be back in a second. Yeah, Siddharth?
Yeah?
Yes, we lost you for a few seconds there.
Ah, okay. So Stephen Hawking, a person who was very, very clever. Okay. And oh, wait, I didn't share with audio. Hold on. Sorry. Okay. So for those of you who don't know, Stephen Hawking was a theoretical physicist. He taught at the University of Cambridge. But when he was quite young, got diagnosed with this disease that made him slowly lose control of his muscles. Okay. But he still needed to be able to communicate. And in fact, the program that he used to communicate was built by Indian software engineers in India. So let's watch this short video and then we'll discuss a bit about it.
My name is Arun Mehta. I wrote eLocutor for Professor Stephen Hawking, which allows a person who is severely disabled to type and speak using a single button. What happened was that when he had come to India, my colleague Vikram Krishna met him in Bombay, and that's how this work started.
I met him, and it turned out that he wasn't this forbidding figure at all. He was just a fun guy, and he loved to make jokes, and he had a serious problem which needed serious attention. And it became so important to be able to be part of developing a technology solution to try and express that humanness, which was so much a part of it, to make it easier for Stephen to express himself as a warm human being. And that coughing sound in the background is not somebody doubting it incredibly, but my poor dog over here who's got a bit of a cough.
Right from the beginning, what we were told was the absolute minimum in terms of what a person can do in terms of interaction with a computer, which is press one switch. So,
So here's the fun thing. They're talking about the same situation. As someone pointed out earlier, Jean Bobby and Stephen Hawking are in the same situation. Hawking can press one switch. Now here's the fun part. Okay, let's see how much information these guys were able to extract from just being able to press one switch.
Condition deteriorated, they found other ways for him to control that switch.
And what was nice about the solution was that Arun had analyzed the problem of somebody who has very, very little movement left. We basically took the ability of a computer gadget, a mouse, the clicking of the button, and took one single click and looked at how many things we could make the computer do with that. And we could do three things with it. One was to sense a click, the other was to sense the lack of a click, and the third was to sense the length of the click. So we took those three aspects, and from it we made the ability to create complete sentences very, very quickly.
So we used only one of those aspects. We only sensed the click. But here, since he's looking at a screen, and the screen can ask him a yes or no question. If he clicks, it's a yes. If he doesn't click, it's a no. And he can click longer and click shorter, and thereby get different inputs.
My name is Arun Mehta.
Oh, yeah. So that was as far as we were going with that video. Okay. So with this, I want to talk about what have we done so far. Okay. Because we're talking about computational thinking, right? So what really does that entail? What does it mean? We focused on communication. Okay, we're talking about how do we transfer information from a source to a receiver. Okay, and we worked in a situation where the channel of information between the source and the receiver is very, very limited. He could just blink. He could have great ideas. The receiver could have lots of capacity to receive, but the channel between the two is really, really limited. And we discussed how to efficiently communicate single alphabets in the context of blinking, printing, and typing. We saw how to create a cost function of sorts, right? How do we estimate the cost of different techniques of doing this communication? We, by estimating that cost, we're able to decide which is most efficient, right? So for example, this difference, the fact that the split 2 and split 6 were not really different in most cases, makes us maybe go with the split 2 as the best option, right? Because that's the easiest, least complicated, but also as efficient, right? So maybe if we make it very, very complicated, we could make it very, very efficient, but having complicated systems is difficult. Okay, and right. This brings us to what is computational thinking, because I've been talking about it. The specific stuff that we've been focusing in this class comes under, at least if you're looking at it mathematically, it comes under a thing called information theory, okay, which deals with this particular, which deals with additional questions. What if you make mistakes? What if there's noise in the channel? When you're sending a message over, if you're shouting a message across and a dog coughs on the side or something happens, can you still send a message in such a way that you're able to reconstruct the original message? Or in the way that we're very used to of like having QR codes, right? The QR code is also a message. Suppose there's some gravy that's fallen on one part of the QR code, right? Or you're reading a QR code in a station and one part is dim. Your phone is still able to figure it out because there are inbuilt mechanisms in a QR code to sense and rectify errors. So what does computational thinking consist of? It involves breaking problems into smaller parts. Okay, so for example, we took how do we write a book, and we broke it down into, okay, how do we say letters in the first place? Once we say letters, then we can figure out how to add space. We can figure out how to add chapter. But I know you were all giving me bigger ideas, different ideas, but I said, no, let's just focus on the letters. We're going to solve one thing, and then we'll move on to the next thing. So this step-by-step doing things is helpful. The second part is spotting patterns. The pattern that we found in today's class was the frequency of letters in the English alphabet. And by paying attention to that frequency, by going from, A, B, C, D to this, right? I'll just make this easier for everyone. Yeah. By going from A, B, C, D to this, we use that pattern to get more efficient. Okay. And then slideshow. Oops. Okay. Then we created a step-by-step plan. Okay. We didn't go all the way in doing this. Like our plan so far was read the letter, choose a card, things like that. And as we discussed with Anya, if you miss a blink, then loop around back to the start. So clear plans, but clear plans will be something that we'll be doing a lot more in the course. Then thinking like a detective. Our plan could have mistakes and we need to fix it. And finally, we need to make smart solutions. Okay, so like we saw in that video for Stephen Hawking, you need to be creative. They took what we took as just one input of there's a blink. They converted it into 3. The presence of a click, the absence of a click, and the duration of a click. They got 3 pieces of information from it. Right? So that's computational thinking for you. And it's entirely, it's related to being able to code. You could be a good coder and not be good at this, in the sense of there are so many programs that are trying to teach you coding when you're 6 years old or 7 years old or 8 years old, but not really going into this, which is fundamentally what do you need to be doing. And you could be someone who has nothing to do with coding. You could be trying to optimize production in a kitchen by telling everyone, and this is something that I have done, right? Optimize production in a kitchen by giving people clear instructions. Doesn't involve a computer at all, but it involves computational thinking. So with that, that's the class for today. And but back to Janani, she has a few more things, and then we'll open it up for questions.
Yeah, thank you, Siddharth. That's a fascinating conversation. Just this simple thing of, really limiting the amount of conversation we can have. Judging by the chattiness of the chat, I feel like we would all have a terrible time if the only thing we can do is blink. We'd have so many ideas that we just can't share. And perhaps we can build ourselves a computer if such a scenario sadly comes across. So there's a lot more to discuss, so don't drop off at the moment. We have 20 minutes before we wrap up the class, and then we'll have further 10 minutes of fun time just chatting with each other. So I want to hear, I'm going to open up the chat. Okay. I want to hear.
I opened up the chat already.
Who enjoyed learning from Siddharth today? Did you learn something new? Did you have an interesting thought from today? So tell me yes. Viraj's favorite is you, Siddharth.
Thank you, Viraj.
Yay, so many yeses. Super. Wonderful. Great. Wow, 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 wow. Okay, wonderful. Lots of yeses. So we are, the point of Gifted World is to have these fascinating conversations, and we'll keep having masterclasses. So I want to see you at the next one as well. And we'll have more stuff up on the website. Keep having a look at it. It's called giftedworld.org. Yeah. And if you really enjoyed learning with Siddharth and you want to learn more with him, then we have a course coming up. So you can have like a whole 5-session course with Siddharth. And because you are, you're a member and you've attended this masterclass, we'll send you a discount code so you and your parents can discuss. And if you want to, book a ticket in his course and come, you can do that. Siddharth, can you share a little bit more about your course and what you're going to do there?
Yeah, definitely. So in this course, and maybe I can just screen share the course page. And actually, yeah, by screen sharing, I'll be able to tell you how to get to the course, which is also helpful. Right. So if you go to giftedworld.org, you can, under online courses, which is not clicking. I think it clicked. There we go. So, and we'll send you this link later as well. So this course is focused on helping you learn stuff through games, essentially. Okay. We've devised a bunch of really fun cooperative games that you'll try out, and sort of puzzles and challenges, which build the abilities to do computational thinking. Okay. And over 5 sessions. So the sessions are on Saturday, Sunday, Wednesday, Saturday, Sunday. Okay. I think we put the details. Yeah. Evenings from 5 to 6:30 p.m. India time. We are going to build up to a situation. The final games that we'll be doing on the final 2 days are things that we were using to test people for admission to bachelor's degrees in colleges. Okay, so we're going to work our way up to those sessions, and you can do this in grade 5. I've already done it with grade 5 kids in a school. Okay, it's a lot of fun. And these are simple games that we'll be doing online to figure this out. We'll also be language. Will be one of the things we'll be doing is trying to reverse engineer a text-to-speech machine. Okay, and all of this doesn't require you to code at all. If you're able to code, it's a bonus. but none of my assignments or things will actually involve you having to type in any programming language, because what we're focused on is the skills, like I showed you about those 5 points of what is computational thinking. What we're focused on is the skills that enable you to think this way. One way that we've used computational thinking is in, as I said earlier, making better recipes for a kitchen, right? We've been able to make better recipes that enable cooks who are largely illiterate, can read only a few things, make great dishes, because we set up the process in such a way. This is not computers, this is the application of the mind. And however much AI gets better and takes over the world, this will not be replaced, right? The ability for people to think and problem solve will not be replaced. So I really look forward to doing this course with all of you, and I'm happy to answer any questions that you have.
Siddharth, could you clarify which grades this is for? I have a bunch of questions about that.
Yeah, so this is for grades 4, 5, and 6 also, if you're interested. For older students, there will be another computational thinking course that Karthik, who's also on this call, will be running in April, if I'm right. We'll be putting that up on our website soon enough.
Super. So if you have any questions, please put it in the chat or raise your hands. I see Samantha and Arnav have raised their hands. Samantha, do you have a question? Yes, I have invited you to unmute.
Some people. Go ahead.
You know the thing where you type a word and that's alphabetical or frequency or split 2, split 3, and split 6 came. Where do we find that?
We'll share it to you on email tonight as a follow-up to the class. Okay, I'll share you that spreadsheet by email so that you can run it on your own computer.
Okay.
Okay.
Hey,
Ashray?
inviting Arnav to unmute.
Oh, sorry. Yeah, go ahead. Janani is running this. Yes. I will not.
So, as you work in ecology, am I right?
Yes.
How can computational thinking be applied there? In what ways and why?
In ecology, there's a whole load of it. Just answering the question, how many species of grass are there in a field, is a very difficult, or how many species of trees are there in a forest, is a question that you need to do all of those things. You need to break down that problem into smaller things, because you can't possibly count all the trees in a forest. And even the question of how do you classify a tree, classification is a very, very fun exercise. It's a very traditional computational exercise where you say, okay, I'm looking at this plant, but what species is it? Are the leaves round or pointed? Are the flowers 5 petals or 6 petals? Things like that. So those are ways in which.
So it can also be used like for finding the most important ingredient for growing a plant, or finding how much of each, like that.
Yes. So I'm seeing that some people are leaving. So I will definitely talk more about this, Arnav. Janani, do you want to run that poll? And while I'm continuing to answer Arnav's thing.
So guys, while Siddharth is answering Arnav's question, I've launched a poll for you. Yeah. If you are interested in the course, you can put in your details here, and then we can reach out to your parents afterwards and share it with them so that they can help you decide if you want to come or not. Yeah. So just put your response in the poll, and Siddharth, you can continue responding to it.
Yeah. So Arnav, the thing that you're talking about, figuring out the most important ingredient, things like that, this course is about computational thinking. It's a way of problem solving, approaching problems and solving them. It can be contrasted to scientific thinking, which is a way of doing experiments and finding truths about the world. They are not opposite to each other. They're kind of complementary, right? And that another way of thinking can be design thinking. which is how, which is another particular way of solving problems. And you can be good at all three, right? They all have, they're kinds of different tools that you have in a toolbox of doing things better in the world. Does that help answer your question?
Yes.
Cool. Next, I see Adit. Yeah.
Yeah, Adit, I'm going to request you to unmute.
I'm the 5-section course or something you said, right?
Yes.
When is that?
So it's starting next weekend, next Saturday, and happening Saturday, Sunday, then Wednesday, Saturday, Sunday, from 5 to 6:30 on each day. So 1.5 hour sessions each day, and there will be about 2 assignments that you do through the course.
So it will just be like this session, but for 1.5 hours.
With a smaller group of people. So it'll be a lot more interactive because there were 130 people here. So we couldn't, like, for example, you were muted most of the time. So that would be more interactive because it will be a smaller group of, say, about 20 to 30 people is what we're looking at. We don't want to do much more than 30 because it will get kind of noisy. So in that sense, there are limited seats for it.
Okay.
Divya, would you like to go next?
Going to ask you to unmute.
Yeah, so I'm interested in the course, but the dates, like the last 2 days don't actually work because I'm going out. So like, will the course be recorded and like, will it happen again?
Yeah, the course will be recorded. It may not happen again. So this is we are not quite sure if it will happen again. The course will be recorded. And what you could do is you could fill this form. We will send you an email or a message, and we can discuss to see how we can enable you to attend the course. Maybe we can have a separate conversation for any doubts where after you look at the recording, something like that we can do.
Okay.
Thank you. Arush, I'm going to ask you to unmute.
So, will there be any courses like in which you can type in actual programming languages like Python and then use it to make some applications or websites?
Definitely, we have a whole calendar that we're designing right now. We'll take your suggestion and we will find an exciting mentor to do that. But it'll likely happen in the summer. So April, May time.
Because right now we're in January and February and March tend to be very filled with exam related stuff. So yeah.
Thanks, Arush. Hamda?
So I'm interested in joining the course. I can join on Sundays and Saturdays, but the timing for Wednesday doesn't work for me. So it will definitely be recorded and sent to me, right?
Definitely.
Yes, definitely. Yeah, we'll record and send it. And also
And is there any possibility that it can be after 6 o'clock in GST?
In GST, that would
what
be
we'll do is we'll reach out to you and we'll just see what we can do to help you. Okay.
Thank you.
Yeah.
Yeah.
Great. Rishi, you have a question?
In the splitting into cards, like when they say like card 1 if they don't blink and card 2 if they don't blink, then you don't even need to show card 3 because obviously if it's not 1 or 2 then it has to be 3. Then
that's a good point.
Why is it counted as 1?
So there is the option that I made a mistake. Right. Remember when I made a mistake with Anya, when I didn't actually record her blink. So if we automatically assume card 3, okay, and we go into card 3, and then we're looping around card 3. So maybe he blinked in card 1 and I missed it. Then I went on to card 2. And then I considered that there was no blink in card 1 and 2 and I automatically went into 3, then that's a problem. So in terms of error correction, I think that waiting for a confirmation before going into a card is better. But that's a great point, Rishi.
In some sense, Rishi's point is what they ended up doing for Stephen Hawking, right? Measuring the absence of a blink as well.
Huh. Yeah.
Thanks, Rishi. Okay, Ashray. I'm just going by order of who I see. I'm sorry if you're waiting a long time. Ashray?
Yes, ma'am. It's about computational thinking. So I knew the story. I didn't don't completely know the story. So I just researched about this. So Rear Admiral Jeremiah Denton, a US Navy pilot, was held as a prisoner of war in North Vietnam during the Vietnam War. During a television propaganda interview in 1966, Denton was forced to speak in support of the US government. However, to alert the US military about the harsh conditions and torture that he and his fellow POWs were enduring, he cleverly blinked out the word torture in Morse code, using short blinks for dots and long blinks
And
for
long blink. Dashes.
long
Yeah.
dashes, and absence of a blink as for space.
Nice. Yeah, so
No, never mind, not the absence of the blink. It was only one word, but still.
right. So that
His
makes sense.
captors,
Yeah.
sorry, his captors didn't notice the convert message, but US intelligence experts did, and it became a powerful symbol of resistance and bravery. Denton was eventually released in 1973 and became a US senator from Alabama.
Lovely. Thanks for that example, Ashray. I know many of you were saying Morse code. Morse code is commonly taught to military people for this precise reason, right? That it's very easy to signal if all you have is, so I know of stories of like you make a fire and you keep covering the fire and opening the fire in different ways such that the fire acts as a blink. There are just so many ways that you can create an on-off. And knowing Morse code is extremely useful. For those of you who want to learn Morse code, all strength to you. I think I have too many other things to learn currently.
I've asked Trinetra to unmute.
Now these new classes, so is it only for silver scholars in asset?
No, anyone is welcome to join if you feel like you can do it. No worry. Yeah, so anyone's welcome to join.
Thank you, Trinetra. Sasi, I have asked you to unmute.
It's Anushka, actually. So I have a question about this computational thinking. What all fields, like in jobs, what will it be useful in?
So jobs wise, it's very like obviously computational related things, but otherwise, as I said, it's a way of thinking and looking at the world. It makes you a lot better at all kinds of things. So it's a way of problem solving. So any jobs where you're solving problems and you're trying to be systematic about things, having fundamentals of computational thinking strong is helpful.
Thank you, sir.
Thank you, Anushka. Omkar, I have asked you to unmute.
Yes, I'm just waiting for that Google Excel sheet to be sent.
We'll send it tonight by email.
Okay, thank you.
Yeah.
Thank you. I've invited Vedakshit.
Actually, I have not decided whether I want to join for the course. So can you send the application later?
Yeah, or you can just fill maybe for now, because maybe means that I haven't decided.
Okay.
And you can always just go to the website just the same way that I showed you and sign up for the course, or email us.
Okay.
You have our email.
Thank you. Arahan, I have asked you to unmute.
What is the fee structure of the course, sir?
Okay. One second. I'm actually responding to you in the chat, but I can share it for everyone. So the full price of the course is 4,900 rupees, if I'm right, Janani?
And also I have another question.
And by attending this this session, you get a coupon with a 20% discount. So if you just put in Encoded when you're getting the course, you'll get a 20% discount, and that brings it down to somewhere around 4,000 rupees. Maybe a little under 4,000 rupees.
And I have another question also. So
Go
how
ahead,
is this
Arana.
guy going to let his eyes stay open for so long without blinking? It is hard for me only. How is he going to do it?
I think
That
that's
is what
why I think that's why I said, right, 3 hours a day, 7 days a week. So he only did it for 3 hours a day. They probably took breaks even within those, like those 3 hours were spread out in the day. That's my guess. That's all that I know of his story. Everything that I know of his story, I have shared with you. But there's a whole book, like there's the book that he wrote, and there's a film about the book that was kind of award-winning and stuff, which I haven't seen. But if you want to see it, the book is called The Diving Bell and the Butterfly. Again, I have no clue why it's called that, but The Diving Bell and the Butterfly.
Okay.
Vedakshit?
Inviting Sai Shayansh.
Oh, oops. I just invited Vedakshit.
So I'll do the unmuting.
Yeah, are there
Cool.
any kind of robotics courses or something?
Yeah, we have lots of courses planned. Just keep an eye on Gifted World. And once that's up, you'll get a notification. We'll also keep, when we put up the new course, you'll get an email about it. So your parents might be able to tell you, let them know to tell you if there's any robotics things coming up.
Okay, thanks.
Thank you. David, I'm going to ask you to unmute.
Yes, so about the way that we got the idea to communicate with the letters. So I actually had an idea that I wanted to share. So what my idea was that we would take the letters in frequencies, but we would divide them into cards different ways.
Okay.
So if you don't mind, could you share the screen where you have listed it by the frequencies?
Yeah, will do. And then you can probably just
Yeah.
annotate. This one?
No, only the frequency one, the previous one. The ET, yeah, this one. So what my idea was, we could divide them into cards. Like the first card would be only E, like just E. The second card would be P and A. The third card would be O, I, and N. The fourth card would be S, H, R, D, and so on.
Okay, so here's a fun part. This is so we can actually, what you're suggesting makes a lot of sense, which is, let's pay attention to this frequency column, right? So you're saying we're more efficient if we pick each card to have roughly the same total sound frequency across it. If we add up the frequencies of all the letters, so in a spreadsheet, you can just do it by, so for example, if I take ETA, that's 30%. You can see the total over here on the bottom right. So ETA is 30%. So if I were try and divide this into 3 cards, maybe 30, 30, and 10. Right?
Yeah,
so
that's
30%.
what I'm doing for this.
And if I go down here, this is another 30%. Okay, OINSH. And then if I go down here, that's another 30% if we go until Y. And then these remaining letters become the last.
Yes.
Right? So you can do this. When I send you the spreadsheet, you can make your own, you can replace one of these with your cost and then accordingly change the name over here and you'll see that cost. Okay, so for example, instead of split 6, I will call this Daivik. And you want this to be 2, 3, 4, 5. We said these 3, right? Yeah, these 3 is 30%. And this becomes 3, 4, 5. It goes until Y for the second card. Huh? No. So the second 30% is just here. 3, 4, 5, 6. And we go 4, 5, 6, 7. And go down until Y. Janani, do tell me if I'm taking too long on one thing. Oh, oops. And the formula went wrong. Okay, and then over here we start from 5 because this is the 4th card, and 5, 6, and that costing continues down till the bottom. Okay, so now we can just
Sorry to interrupt, Siddharth.
Yes.
Anyone else who needs to go and you have a question, put it in the chat. I'll respond to you there. Siddharth can continue.
Right. So surprisingly not that different, right? So Daivik's formula makes a lot of sense. I get the feeling that I might have done my formula wrong. Give me a moment. Okay, folks. Here's the kicker. That entire formula was wrong. So the reason that split 2 and split 6 were the same was because I did my formulas wrong on the sheet. Haha. So Daivik's thing is a lot more efficient. And it turns out that maybe that split 6 was a lot more efficient. Even for hello, Daivik's formula is more efficient. Thank you for asking me this, Daivik.
Thank you, sir.
So if I just take a small part of supercalifragilistic, there, see? Okay, nice. Next person. So I'll send you the spreadsheet. You can play around a lot with it.
Yeah, sir.
Yes. Pranav, I'm going to ask you to unmute.
I was just gonna ask if you could like put the 5 to 6 class to 6 because I'm gonna come back home at 5:30. And is there going to be any teaching of codings in the course, like the basics?
No, this code won't be, we won't be doing syntactical coding. So we won't be coding in a computer language. We will be writing algorithms and instructions out in regular language. And we'll be practicing making regular language more effective. So in that way, it will be pseudo coding when you sort of write code, but in regular language. We're not trying to deal with the difficulties of syntax, which is getting the exact language of coding right.
The point being, Pranav, is whatever you end up learning as a computer language later in life, this is going to supercharge your learning process there. You'll be much better able to code in whatever way you choose to do so.
Okay, thank you.
Thank you.
Yeah.
Kabir, you've been very patient. I'm asking you to unmute.
Thank you, ma'am. Actually, I have a question for Siddharth, sir. It's not really related to this course. It's just something I wanted to ask you. Do you remember that RF conversation?
About?
The one where that guy said that there were too many RFs and all that?
Okay. Yes.
Question.
Okay, what about RF?
Did that remind you of the first session from Junior Detective where there were 2 Siddharths?
Yeah. Yes. I mean, there are lots of people with common names. So thanks for remembering that, Kabir.
Okay, I'm just gonna mute my.
Sure. Shiv, I've asked you to unmute.
So, sir, my question is, when we divide it, the frequency into 3 or 6 types, maybe we can ask if it's a vowel or not, because that will save a lot of time.
Yeah, that's another way we could categorize it, of vowels or not, right? So if we add up the vowels, I'm curious as to what the costs are, but I mean what the frequencies are. But you're right, vowels are. So finding once we have this, what you're showing us is once we have this general algorithm, right? We have this algorithm of split up letters into cards, and an algorithm is just a structured series of instructions that enable us to do things. Split up letters into different cards, show the cards. If the person sees the letter they want, they blink and they choose that card. Then read out that card until they blink and they choose that letter. Now, we're discussing ways to split up the cards to make that algorithm more efficient. Once we set upon this algorithm, we're trying to make it more efficient, right? So there are several splits you can try out. And once I send you that spreadsheet and you change the costs in whatever way you like, you'll be able to sort of try out whichever ones you want and email us if you find even more efficient ways. It'll be fun.
Thanks. Sayani, I'm going to ask you to unmute.
Ma'am, can I let to know if there is any app so I can review all the recording classes and all my courses?
So all the recordings for the master classes are up on YouTube. And we
this
will
one will be as well.
All the recordings. So on YouTube, you can go to Gifted World. It's a channel. You can see all the master classes that we've done. And there's a whole bunch of interesting things. Yeah?
Okay, ma'am. Very much. Okay, ma'am. Thank you, ma'am.
Thank you. Adikshita, did you have a question?
Oh, she put her hand up. Okay. Wow, we made it through all the questions and it's only 15 minutes over.
Great. Thank you all. So Sumukh had a question in the chat, which is whether we can get any certificate for joining this masterclass. So we don't give out certificates for the masterclass, Sumukh, but we do give it out for the courses because the masterclasses are a way to find interesting conversation and to just chat and to learn new things. And the courses is where you'd actually put in a little bit of work and finish all the assignments and we can certify you for that. If anyone needs to leave now, please feel free. If you still have another question, you can hang out with Siddharth and me and ask us. Otherwise,
and we found one person. Oh, sorry, go ahead.
Yeah, we'll see you in more of our master classes. So I see Araya has a question. Araya, I'm asking you to unmute.
And we found